Today we are continuing our work on the Unit 1 test review. So we're picking up on number 6 today. It says, how many solutions does this equation have? So you can either have one solution, infinitely many solutions, no solution, or two solutions. So you can go through and you can actually solve this and figure out how many solutions by getting the actual solutions. Or remember, there are a little trick that we can do using the coefficients and the constants to get you to the answer a little bit faster. So remember, the coefficient is the number that's in front of the variable. So for example, the coefficient here is 9, coefficient here is negative 20. And constants are the numbers that don't have a variable attached to it. So for example, 3 is a constant. This negative 3 over here would be a constant as well. So what you want to do before you assess the coefficient and the constant is to make sure you have combined any of your like terms on both sides. So let's take a look at this left-hand side. I see two like terms, 9x and negative 20x. They're like terms because they both have an x. So if we combine 9x and negative 20x, we have negative 11x. And then the 3 we can add there. It doesn't have any like terms. And here on the right-hand side, there are no like terms. However, notice there's a negative outside the parenthesis. That's like a negative 1, and this is the distributive property. So we'd multiply negative 1 times 11x and negative 1 times negative 3. So negative 1 times 11x is negative 11x. Negative 1 times negative 3 is a positive 3, because remember, a negative times a negative is equal to a positive. Now, we can't combine anything more on the left-hand side. We can't combine anything more on the right-hand side. From here, if we were actually solving, we'd move on to getting all of our variables on one side, everything else on the other. But we're actually going to pause here and use our shortcut, our trick. Let's look at the coefficients. Our coefficients here, I'll highlight them in blue. The coefficient is the number in front of the variable. So we have a coefficient of negative 11 and the coefficient of negative 11 here. So on both sides, we have the same coefficient. And let's look at the constant. I'll highlight the constants in red. The constants are the numbers without any variables attached to it. What do you notice about them? They're both the same. They have the same constants. So when you have the same coefficient and the same constant, the right and the left hand are the same, that means there are infinitely many solutions. Why? Because it does not matter what number you plug in for x. Because you're doing the same thing, multiplying it by 11, then adding 3, on both sides, the left and the right side will always be equal to each other. So our answer is infinitely many solutions. Now let's take a look at number 7. Number 7 asks us to solve for c. They give us this equation and we're trying to solve for c, which means we want our answer to look like c equals something, which means we're trying to get that variable c all by itself. So let's rewrite it here. AB equals c minus d. We want c all by itself. What's on the same side as c that you don't want? That negative d, minus d. So we want to get rid of it. We want to move that minus d to the other side. How will we do that? How will we move this to the other side? We're going to subtract. Let me go back here. It's already being subtracted. We're going to add d to both sides. So your d's cancel out. And we have ab plus d. Right? You don't have to do anything more. You don't have to put them all together. You just write it out. AB plus D equals C. Now, I know we're done because this C is all by itself, right? We said we wanted our answer to look like C equals something, which it does. So we're looking for the answer that matches up AB plus D. Can't be this one because it's a minus sign. It's not option 2. We're not dividing. Option 3 looks pretty good, but I'll look at option 4. Option 4 is multiplication. We're not multiplying. So our answer is option 3, AB plus D. Now let's look at number 8, solve for x. Now, the rules that we just did for number 7 are still the same rules here. We're trying to get x by itself. But we now have an inequality. That's okay, the rules don't change. X plus 4 over 3 minus 8 is less than or equal to negative 2. So even though here we're solving an inequality, it's still the same steps as when we're solving for different variables. We're still adding, subtracting both sides, multiplying, dividing, trying to get a variable by itself. So we're trying to get x by itself. What's on the same side as x you don't want? Well, we have lots of things. There's the plus 4 divided by 3 minus 8, all those. And we're going to get rid of them step by step. So we'll start by getting rid of the minus 8. How do you get rid of this minus 8? We'll add 8 to both sides. So your 8's cancel out. We have x plus 4 divided by 3 is less than or equal to not negative 2. I have to actually combine negative 2 and 8, and I get positive 6. Now, we want to get rid of this 3 on the bottom. This line here indicates what? Division. So, 3 is being, x plus 4 is being divided by 3, so we'll do the opposite and we'll multiply both sides by 3. Multiply both sides by 3, so your 3's cancel out. We have x plus 4 is less than or equal to 6 times 3 gives us 18. Notice I didn't need to flip the sign because I wasn't multiplying or dividing by a negative. Now, plus 4 is on the same side as x. We don't want that. We need to move it. So we'll do the opposite. We'll subtract 4 from both sides. So our 4's cancel out, and we're left with x is less than or equal to 18 minus 4 gives you 14. And there's our answer. So not option 1. We're not, no 18, no negative 18 in option 2. Option 3, what's the problem here? The sign is facing the wrong way. So our answer is option 4. X is less than or equal to 14. All right, let's take a look at number 9. Which equation would you use to model this problem? Aaliyah spent $35 at the county fair. If it costs $15 to get into the fair and $4 per ride. If it costs $15 to get into the fair and $4 per ride, that didn't make sense. If X represents the amount Aaliyah rode, choose the equation that represents the amount Aaliyah spent at the fair. So, what do we know? I'm going to highlight some important information. She spent $35 at the fair. It costs $35 to get in and $4 per ride. So let's start with what we highlighted in blue here. She spent $35 at the fair. What does that represent? That's our total. So I'll put that at the end of the equal sign. That's our total. And then it costs $15 to get into the fair. Is that a one-time fee or does that happen multiple times? Well, she only goes into the fair once, right? And I'm assuming if you leave, maybe you get a bracelet, you only have to pay $15 once to get in. So that 15 sits all by itself. We don't need to multiply it times anything. And it costs $4 per ride. How does that show up in our equation? $4 per ride. This word per here tells us to multiply. And we know X represents the amount of rides she rides. So $4 per ride will multiply $4 times the number of times she rides a ride, which is X. We don't know it yet. So it looks like 4X. And there's our equation. 4X plus 15 equals 35. So let's go through our options. Option 1, nope, it's not $15 per ride and $5 to get in. Same thing with option 2. Option 3 and 4 look really similar, but notice we need to add the $15 that it costs to get in. We're not taking it away like they did down here. So it is option 3. Okay, let's look at number 10. Amanda rented a bike from Shauna's Bikes. They charge $2 per hour plus a $10 fee. If Amanda wants to spend no more than $27, which inequality represents the amount of money Amanda wishes to spend. So now, similar to the last problem, we'll be writing not an equation, but now we'll be writing an inequality. So if you look at your answers, notice no equal sign, we have inequality symbols. So what do we know? We know they charged her $2 per hour, there's that word again, and then a $10 fee, and she wants to spend no more than $27. So there's that word per again. And what did we say last time per means? It means to multiply. Oops, I'll write it here. It means to multiply. $2 per hour. We don't know how many hours they spent. So that might be our variable x. A $10 fee, that's a one-time fee. Spend no more than $27. So let's start with this part, the spend no more than $27. 27 is our total. No more than $27. Here's where I ask myself, if she wants to spend no more than $27, can she spend more? No. Can she spend equal? Can she spend equal to the $27? Well, 27 is no more than 27, so yes, that's fine. Can she spend less than? Sure, as long as it's no more. So we're looking for the less than or equal to symbol, which looks like this. So now what goes into that $27 cost? We know there's a $10 fee. That's a one-time fee. So that shows up just as 10 all by itself, no variable attached. $2 per hour. $2 per hour looks like 2x. We're multiplying $2 per the number of hours. So we're looking for, I notice I used x as my variable, so I'll just rewrite that as h because there's h's in our answer. So it's 2h plus 10 is less than or equal to 27. So option 1, this 10h means that they're charging $10 per hour. That's not true. It's a $10 one-time fee, so it can't be option 1 or 2. The difference between option 3 and 4 is the inequality symbol. This first one here in option 3 is a less than symbol. What does this inequality symbol mean? That is a greater than symbol. So our answer is option 3.